All right, hey, thanks everybody for coming and for watching. We had a 2 months break, but we're finally back, hooray. And I'm going to share my screen so that we can actually look at the presentation. Today we're going to JavaScript everything, especially our tests. I actually have quite a bunch of stuff I wanted to cover. I'm hoping when I'm talking too long, you let me know. When I'm going too fast, you let me know. And when I'm skipping something that I should probably be talking about, please. So first of all, brought to you by, as on our slides, me and that person who's sick and not here, probably watching on our live stream, Eric. And as always, a big thanks to the sponsors, Assembly, who sponsoring this awesome space, and this fantastic PA, which actually allows us to stream it all online. It's on YouTube, so you can watch it. We might write a summary about it eventually, too. I did that for the January meetup. There's a link in here as well. Startup Calgary, we teamed up for them for Hack Nights Tuesday. Every Tuesday is Hack Night. There's Chic Geek hosting. The third Tuesday, I'm going to mess it up. Sorry, Chic Geek, WordPress, Meetup, and the Ruby guys, and us. We are the four that co-host with Startup Calgary Hack Night every Tuesday. So it's worth coming here almost every Tuesday. Village Brewery gives us a deal on beer that Petrofeed is paying for, so thanks a lot. Beer is free, so feel free, or all the drinks are. Feel free to grab some. People have usually been pretty good and left everything for me. And yeah, quick recap because we did a 2 months break. What did we do? First, in February, we had something titled JavaScript, the Weird Parts. I actually wrote a blog post with the summary. It got some pretty good feedback. I hope it's a good read. There's also the recording from the meetup. So if you want to follow up and see what we've been talking about earlier, we talked about jQuery. We did a Node.js introduction. Eric talked about in May about how to optimize your development workflows and things like that. A couple of those things are definitely going to show up today too. And then in June, we had a discussion about why you should use a framework, not necessarily which one, but what to look for, what to do, what not to look for, things like that. And today, we're going to talk about testing. So there's a long list, like I said. I'm going to start with manual testing, which is probably what everybody's doing, but there is a couple of tools that make it easier and help you actually catching tests that you can't, like testing on a device that you don't own. Mobile remote debugging, that's partly in there for me because every time I have to set it up, I forget how to do it, which means we're going to set up iOS and Android to actually be able to inspect when it throws errors and what problems it has. Then I'm going to talk about unit testing. We did this last year. Who was here last year? I know Brett was, Olivier was, Kevin was, Patrick was. So we did some of this might sound familiar. The cool thing was last year we actually did some coding session. We weren't that many people, so we split it up, and people actually did write some tests. The good thing for me was now I can use it in my presentation and not have to write it myself. So we talk about unit testing quickly. I'm going to show you the demos. And then because JavaScript unit tests run in a browser, I'm also going to talk about, well, great, I'm going to open it in my browser, look at it, and see that everything is passing. But I don't want to do that every time. So a way to automate that, which is part also of continuous integration, which means I'm going to send my code to a server, and it's going to run the tests for me and shout at everybody who broke the code. And the last part, which is interesting and still pretty new, is doing functional testing. So actually having somebody click around on your website and see if it breaks or not. And if I don't talk for too much, we might even be able to do it all together in one thing. So let's start with manual web page testing. Why do we have to do this? Well, there is still a browser war going on. I love this one. I had to put it in. Oh, now people got it. OK. I'm going to let this sit for a little bit longer. A lot of the web now is standardized, but even standards are open for interpretation, and also it takes a long time for people to actually agree on a standard. So Google has the resources of actually implementing features that haven't even been standardized yet, which is cool for us as developers, but it also sucks because that means not everybody else is doing it, especially that kid eating glue. The new problem that came up lately is you have tons of different devices, tons of different size resolutions, all this stuff. This is the Open Device Lab in Helsinki. I happily support any initiative to get something like that going here. Basically, it's similar as, I think it's a co-working space that hosts it, and people just sponsored a whole bunch of devices, and you can go in there and open your website and see if it looks good on all this stuff. It's a really cool idea. They wrote a neat little tool to actually open your website on all those devices. I think I'm going to show it in a little bit. So that's the other problem. And I would think everybody is kind of testing their websites manually to one extent or another. There are some tools that make it easier. Now, mobile is a big thing, right? So I'm going to focus on that a little bit more. And cross-browser tests, of course. So the tools that I wrote down here is xcode. I think they have a Windows version. Correct me if I'm wrong. Also, if there are tools that you use and really like, please let us know. We're going to add them to the list later on.
xcode is only Mac.
It's only Mac, right? OK. If you want to test iOS devices, you don't get around at least owning a Mac. You don't have to own the device, but you have to own a Mac. You have to install xcode. You can do that from the App Store. It's free. You don't have to start xcode to start the iOS simulator, so I'm just quickly going to show you where it lives. If you installed xcode, it actually lives in, you go here, open, show package contents, and then contents applications. So here's the iPhone simulator. You can actually just drag it in here, and then you'll have it available for just quick access. I never start xcode, but I need the iOS simulator a lot. iOS simulator works pretty well. There is the Android SDK that comes with Android emulators. I have never ever managed to get one running with the Android SDK, and that took me 3 hours. If you can get it running, that's good. If not, there's a new tool that I actually ran, come across. Sorry, I don't know how it's pronounced. They're from Europe. Genymotion, I don't know. They have a neat little package that you install. The basic version for personal use is free. I think it's 100 euros if you want more emulators and things like that. But you install it, you start it, yeah, like this. I installed it yesterday because I had to do a lot of Android debugging too. And then you can actually say, OK, give me HTC One. So you can actually emulate all those devices just like this, and you don't have to spend 3 hours setting the Android SDK up. They download it, and then you can just start it, and you have an Android device running on your emulator. It's also pretty fast. I don't know how they do it, because the Android emulator has the bad habit of being horribly slow, but it's gotten better, granted. So I might use that in a little bit. I do have an Nexus 4 here, and I'm going to wire it up, so maybe not. But this is a really cool tool if you need to test on Android and you don't have the device. Every bug that we had that was device-specific, because there are a lot, was actually reproducible on the emulators, so you don't need to own the actual device. Modern IE, it's an initiative by Microsoft admitting that IE sucks. It doesn't even open. I think I broke the link. Anyway, modern.ie, they give you free credits for testing IE on Browser Stack. They give you free virtual machines with Windows XP, Windows 7, Windows 8, whatever, with every version of Internet Explorer. I installed it in VirtualBox. I have IE 11 and IE 8 that I generally use. Problem with IE 8 is you have to reactivate your XP version every 30 days, what you basically do is you keep the package and just unpack it every time your Windows version expires. So that's pretty helpful because in a VM, it's still a lot faster than testing anywhere else. Now there's two cool tools, Browser Sync and GhostLab. Browser Sync actually synchronizes all your browsers across multiple devices. So you can run it, it's a node server, and whenever you change, let's say a PHP file, it automatically, or a CSS file, it automatically reloads on every device that you have it open on, which is really helpful if you want to test it across devices. GhostLab kind of does the same thing, but sorry, my browser. Oh, look, it actually did work. I don't know, it's being. So this is modern IE. It looks like Windows 8. GhostLab, it actually has a mobile app, so you can create tests on your mobile device and then synchronize it across other browsers. I think it's $50 in the basic version. So not all this stuff is free, but it's definitely worth it because it's a pain trying to do it yourself. And then there's the remote web inspector, which basically emulates the Chrome this web inspector, but injects it into another device. We're going to do remote debugging with Android and iOS. I haven't looked into this one yet, but it's good to know. Now we live in a service world. There's a couple of services too. Sauce Labs has really stepped up their game lately. They're doing a good job for running automated tests on actual devices. So you upload your Selenium tests, and then they run them everywhere for you. And they have little robots that test for you. I looked that up. Here, Sauce Labs robots. They built a prototype of a little robot that actually touches and does stuff for you on a mobile device. It's pretty cool. Notebots. If anybody's interested in notebots, I've been trying to do that for 2 years now. Maybe we'll eventually even be able to. Browserling and Browser Stack is cross-browser testing. They should pay me money. I mention Browser Stack almost every time I talk about testing. Basically what they do is you get a whole bunch of operating systems. Android and iOS are on the emulators, which means it can be very, very slow. So for real testing, install it on your actual device because doing it through Browser Stack, through the virtual machine, is almost unusable, but sometimes it helps to run tests automatically. So let's say we got to test something on IE8. So here, this is, by the way, the domain github.com/icjs, where you should go to see the presentation and all the demos that I'm going to do today. And then you just say start testing, and it actually goes onto Amazon EC2 and sets up a VM for you. And then you can use it through your browser, which is actually pretty useful. I used it a lot, and because they have an API, it's really nice to automate your tests. So it can be a little slow. It's gotten a lot better, and it's very helpful if you don't have the browser available, which is true for older versions. So now that I show Browser Stack once again, so those are all pay services. You pay a monthly fee. And Browser Stack has, I don't know, they keep changing their pricing model, but for the actual manual browser testing, it's pretty good. They have other things where you can automate your tests, where you can take screenshots on different devices, things like that. Pardon? Olivier just said Sauce Labs is free for what? For developers? Yeah. I haven't used it yet, but those services, just look at them. I've been using Browser Stack a lot because it was one of the first round, but I know there's a lot of good competition going on right now, and it's worth looking at all of them and see, is it fast enough, how is the pricing, things like that. Keynote, Device Anywhere, I think it was, they have a giant, pretty clunky IDE, but the cool thing you can do is that you actually can requisition real devices on their server farm that you can do actual tests with. I used that when BrowserStack was too slow to emulate the Galaxy S3, and it worked pretty well. So if you really, really need to test on an actual device, they also do it through different providers. So you can say, I want the S3 going through AT&T with this internet connection speed. So it's really helpful if you want to test how your page behaves through different services and devices that you don't own. Okay, here's a picture of the first computer bug ever. To Grace Hopper, who actually did the job of debugging this first computer bug. I did a link to what I wanted to write up, because I wanted to write that up. Smashing Magazine did a pretty good job in writing all of this up on how to do remote debugging, but I wanted to actually show it. iOS, those are the things you got to do to actually enable remote debugging. So if your app breaks in iOS, you go to, let's go through it. I'm going to start the simulator. Yeah, I'm going to close this. Let's see if this works from the screen size. Oh dear. This is always an unknown. What is the screen size you're actually going to get? Oh, thank you. Zoom scale 50. There we go. Thank you. So you go in. This also applies to the simulator and your actual devices. You go to Safari, and then Advanced, and then Web Inspector. So you enable that. And next step, let's go back. Connect to your Mac via USB or start the iOS simulator. We started the iOS simulator. It's easier to see. Open Safari. Come on, Safari. And then you have to enable the develop toolbar. So you actually have to go into Advanced and then say show develop menu bar. So that's why I actually wrote it down for myself too, because I keep forgetting that. And then it'll actually show up here. So it says no inspectable applications. Let's give it an inspectable application. For example, our broken website. Uh-oh. Thank you. See, I don't use it. I don't use the simulator that much. Maybe just to start the browser. What was it, Kevin? Sorry. Thank you. So we can go to now technology is okay. There we go. We can actually look why our website is breaking. So we go in here in develop, we'll see the iPhone simulator, and I can close this. And then we can actually go and inspect individual parts of the page and also run JavaScript in the console. So you can run your JavaScript on your iPhone, iOS device, or the simulator. So this is pretty helpful. You might need it a lot. It works the same when you plug in your iOS device. For Android, it's more fun. You go to Settings About, and then you tap the build number button 7 times. 7. That would remind me of Monty Python, the holy hand grenade. 3 is the number you shall count to. So you do that, and then you'll see developer options in the settings menu if you go back, and then you check the USB debugging that it's enabled, and then in Chrome you can actually go to Chrome//inspect. Why I want to show this, it's kind of the same as this. But why I want to show this is actually a neat feature that the newer versions of Android have. So I'm going to plug it in. It's already enabled. So it's connected as camera. USB debugging is enabled, so I go to Chrome, inspect. So I see that it's connected, my Nexus 4. So if I go to a website, this only how it works with newer versions of Android. Oh, actually, I can even open the website in here. You can go to inspect, but then you'll actually be able to see. So this is actually mirrored off your screen of your device. So you can actually operate it through. Yeah, I didn't know that. So it was. I saw that, and when I looked it up, it's like, this is pretty useful so that you don't always have to skip around and touch and do stuff. So you can do remote debugging on your actual device through Chrome, and you get the screen. The cool thing is this works obviously remotely, so you can requisition devices from other people. Device Anywhere, what I talked about, actually do that. They have an option to set up a virtual USB port, so you can do this thing while having a real device available that is not owned by you, that's sitting somewhere in a data center. And it's cheaper than buying them, because an S3 is actually still pretty expensive. All right, I'm going to close this, or not. I fail at navigating today. So those are, I think, pretty important for debugging mobile devices. And probably the most important things, it comes up a lot now to actually have your website work on mobile devices as well. And it can be a pain. On older Android browsers, like the Galaxy Tab 3, which is a horrible browser. It's kind of like the new IE6. You can't do remote debugging because Samsung sucks at bringing out updates to Android. And you can, in the address bar, you can type about debug, and then you at least get a console and error messages in case you didn't know it. We're just doing QA for the project I'm working on, and a lot of the issues are the Android default browser. Also, iOS, when it comes to scrolling, is pretty horrible. Just throwing this out there, if anybody ever wonders. Position fixed headers? No. So that's fun. You spend a lot of time with that. And it's important to actually have the tools available to actually dig down to it. So that was the manual testing part for remote debugging. How long have I been talking? Is it time for a break? That was 25 minutes? Yes. So let's split it into 3 parts. So I'm going to do 3 times 20 minutes. Let's do a 5-minute break. Now, this was a little bit of a warm-up. The next thing we're going to do is unit testing with JavaScript. So 5-minute break, and then we'll be back. All right. I'm just gonna go on. It's been like about 5 minutes. I also messed around with our Hangouts, so I broke it. All right. All right, let's get back to it. Unit testing. This is actually not. So Daily.js is a pretty big JavaScript blog. They usually make a survey every year, and about 75% of the respondents said, I'm not testing enough or not at all. And unit testing is kind of part of it too. About 50% said they write occasional unit tests, but not enough. And yeah, it's tricky, but it helps a lot in building confidence in your code. And well, what is it? Well, you split your functionality into self-contained units that you can write automated program your tests against, which makes sense. Writing unit tests, actually not test-driven development, but actually just writing tests even after you've done it, helps a lot in actually thinking about how does my API look like? How does my module look like? This is pretty horrible to use. Maybe I should change it. Things like that. And in JavaScript too, each function, each object should perform one unit of work. So it shouldn't do like 5 different things, because in reality, you want to have 5 different classes, objects, functions. It always depends. But one thing should not do 20 things at once. That happens pretty easily when you're just trying to hack away some jQuery. You throw it all in one file, and it'll be a 2,000-line file that does, well, everything. And then you need to add functionality, and then you put it in there. So that is actually where unit testing helps, because it makes you think about maybe this 200-line function that I just wrote is not as good as I thought it would be. Don't write tests for every scenario. It's always a tough balance to figure out with what you actually need to test and what not. But usually it's edge cases and error cases that are the things that need to be tested, because the general case usually works as expected. But when you have edge cases where an error is thrown somewhere, that's when things get hairy a lot, especially in Node. I don't have it in there. So okay, if you have time later on, we definitely can. Would you want to talk about mocking libraries, or?
No, I just more philosophical.
Okay, so yeah, Kevin was asking.
What you should mock, what you should
Yeah.
But if you don't want to tackle it,
So first of all, mocking for unit testing, you want to test a unit of work. What you do with the mocking, if you didn't know, is you replace the functionality that you depended on with something that has a result that you know, where you know the result. Let's say you're making a weather call of the current temperature in Calgary. You want to test your temperature widget. What you would do is you would mock out that response with the temperature right now is 18 degrees. So you know that when you write your unit test, that your weather widget will always show 18 degrees. So that's the idea behind mocks. And you can go pretty crazy, because I've seen, and if you don't know, I'm doing consulting for JavaScript projects, bigger ones. I've seen people start mocking out like also, if you have libraries, you should use libraries that have tests. And if they do, you can expect that the library behaves the way it's supposed to. And if it doesn't, you go into GitHub and create an issue. That's how open source works. much appreciated if you have a good description and a breaking example. Go to GitHub, create an issue, and say, hey, I did this thing. Here's what breaks. And if you want to make people really happy, you go, here's a unit test I provided for you that's currently failing. That's the best thing you could possibly do when you report an error to an open source project. Please don't just say, doesn't work. Doing this doesn't work. I was like, okay. So splitting it up into units, maybe if you have time, we'll go into mocking and when to do it and when not. I think that's an interesting philosophical question, but also something where there are a lot of different opinions. Don't write tests for everything. That's important. Well, Eric, that's an Eric sentence that I thought made sense. Try and kill as many birds with one stone. So write your tests in a way that they cover everything you think it should do. I like doing it when I write a library, writing my tests so that they also make good examples for the documentation, because then, well, you don't have to write documentation. You just copy and paste it out of your tests into your documentation file, and then people can actually use it. So that's actually pretty useful. That makes the test more descriptive. One thing I'm going to mention, because I'm a big fan of it, is has everybody heard of don't repeat yourself? It's like a big thing. That was why Ruby got so popular. Unit testing, in my opinion, and that has been shaped over 8 years of JavaScript now, is the only time when you have to and should repeat yourself. Because if you're trying to make this elaborate constructions of how you test your stuff and set it up, people can read it. If you look at your test, you should know what this specific individual is doing, and you don't have to click through like 20 different files to actually know what this single test is doing. Plus, that forces you to make sure that setting up your tests and running your tests is as simple as possible code-wise. So this is my personal philosophy. It works for me. I hope that's something you can take home too, because even if you have to type it out every time, it's annoying, but it helps everybody who looks at the tests. Is like, oh, okay, this is being done 10 times. That's fine. It's easier to look at something that's the same thing 10 times than figuring out one time in 20 different files. So what's out there for JavaScript? Now here's the thing. People like to argue about libraries and things like that. They all do the same thing. You have your unit of JavaScript that you want to test. So you throw some stuff at it. You make sure that it returns what you expect. And you say, OK, my test passed. And if it doesn't, then your test failed. That's what unit test libraries do. The three big ones, they actually happily coexist with each other, which is kind of nice, are Jasmine, QUnit, and Mocha. Jasmine in version 2 runs in Node as well, right? Brett, you're using it. Runs in Node as well. Mocha also runs in Node. That's why it's been seen a lot of adaptation. It runs in Node and the browser. QUnit is what John Resig wrote when he wrote jQuery, and he got annoyed that there wasn't anything to test your JavaScript. So QUnit has been around for quite a while. It works also pretty well. They all work very well. It's sometimes just a matter of style, how you want to write your tests. Let's quickly look at it. And here we come to the code that the JavaScript YYCJS team from last year wrote. Well, I wrote the blog post, but the tests that I'm showing after. Sorry. So what we want to test is this thing. It's a blog post class. I think it's a little small. I'm sorry. And it doesn't get any bigger. We want to have a title, the content of the post, and the date when it's been published. And then we want to be able to publish it. And toString returns the HTML version of that blog post. So it's a pretty simple, trivial thing, but this runs in Node and in the browser as well, which is nice because then we can test in both sites. toString, when it's not published, then you throw an exception that is not published. If not, you return a bunch of this HTML as your string. So let's look at QNet first. I didn't have enough room to actually test that if I try to toString an unpublished blog post, it throws an error that didn't fit. But this is how you use QNet. You say, hey, module is blog post test. First test is that the date is set to current time. And then you have a couple of global assertions that you can make and say, hey, OK, let's make sure that the time of the current date is the same as the post time if you look back. If we don't pass a date up here, we're just setting it to the current date. So this is some of the logic I want to test. So we're just making sure that they're the same. And then we'll make sure once it's published that it returns the HTML that we threw up in here. So new date is now, hello world is title, hello. And then this is the don't repeat yourself thing I meant. We could set the title and the content, but then you're basically copying this whole logic, kind of. So I'll type it out and say, hey, make sure it's about this string, except for the time, because it changes. By the way, time zones and testing and times in general is also a huge pain, about as bad as iOS scrolling. I worked on a project where it failed only on the day after daylight savings time in Illinois, between 8 and 12. So I talked to people because they were 2 hours ahead, and they were like, yeah, it's working again. So the bill broke for 4 hours, and they were like, it's working again. And I tried it here, and it broke for me. So it turned out that there was some time zone issue difference, and that the server that actually runs in Greenwich time didn't have daylight savings, and everything blew up. So there's weird stuff that can happen with time zones. I know everybody here is more aware of it because it's a big country. Where I'm originally from in Germany, you only have one time zone. So when people ship their applications to Spain or to the US, bad things happen because nobody ever thought of testing different time zones. And everybody always says, well, just do it all in standard time. It's not that easy, unfortunately. So this is QNet. Mocha looks a little different, but that's basically the idea, the difference in ideas. You say describe blog post tests, and then you pass it a function, and you can nest as many as you want. So you can put a describe function and a describe function, and your actual assertions and your tests look like this. So we say what it should do, and then we do the same thing. And here you just say assert that now get time and post date get time are equal, assert equal, it should actually be. So you have the same thing, you have different assertions that you can compare against. There is different styles of testing. Jasmine does it by default a little differently. You can add that functionality to Mocha as well. Jasmine says expect post.publish to be true. Expect post to string to contain post.title. So it's mainly a philosophical thing on how you make your assertions. People really like it because this is really easy and nice to read. Jasmine 1 asynchronous method testing was horrible, but they fixed it in version 2, so they're up with the time now. So it's, like you see, it's mainly a difference in philosophy. Let's quickly look at how they run, because now I talked about it and how to write them. So I put them JS test master. If you go to GitHub, in this repository, you'll find in master. Sorry, I'm going to change this. You are going to find Jasmine Mocha QNet tests. Those are the tests that we wrote last year, mostly, I think. I just made it use Bower, so you have to do Bower install so that it gets all the dependencies, like QNet and Jasmine and jQuery and all this stuff. Eric talked about that in the workflow session, so if you don't know what I'm talking about, it's online. There's a video. So here's the blog post, same thing, and then the different tests. And here is the same thing. This is to make tests asynchronous if you're doing some AJAX stuff. But this is basically how it looks. 3 assertions and 3 pass. A really great win. Same thing, Mocha. Looks a little more minimalistic, but it's the same idea. It also shows you how much it's done, like how many tests it's run, and the duration. And Jasmine, I'm still using version 1. I'm sorry. Looks like this. So it's basically all the same idea. Try them all out and then see which philosophy of how to make your assertions you like most. So what we just did is we opened it in the browser, ran it, looked at it. It's like, oh, cool, OK. Now I can go ahead and forget about it. Unfortunately, you can't just forget about it because you're changing your code every time. So it's really annoying to actually go back and I changed my code. I rerun my tests. This can take a long time. I had tests that took like 20 minutes to run. Wait for it to pass, and then I continue on. So what do we want to do next? Is actually automate that stuff. Are we going to make a do break? No. No, not going to take too long. And this is how we run our tests. Oh, there. The first thing we need to run our tests automated, or one thing we could use, is headless browsers. A headless browser is basically a browser without user interface. Why does that make sense? Well, you can throw your test page at this browser, like Phantom, which is probably the most popular one. You can throw your test page that we just had up here and let it run, and then look at it programmatically and say, hey, all this stuff just passed. And then there's Zombie, which is written in CoffeeScript. Eric scolded me for putting this still in there because the development hasn't been very active lately. But it has an API where you can make login, like type stuff and login forms and things like that. The good thing about a headless browser is that it works fast and it's easily to automate. Well, bad thing is it's actually not a real browser. They have their own little quirks, so you're testing a specific browser, and sometimes stuff obviously breaks. Although Phantom is using WebKit, so you're kind of on the safe-ish side of making sure that your stuff works in Chrome, Safari, iOS, all those Android. Now, who is familiar with Grunt? All right, so it's one of those tools that we used. Basically, there's a Grunt plugin that does exactly what I just explained. It runs this test in a headless browser and then puts the results back on the command line. I actually quickly want to do this with our QNet test. There's a Grunt QNet plugin. So what I want to do is run this from the command line and get the results back. So let's open this. Here's a Grunt file. And then I say, this is our plugin. So we say, hey, load Grunt contrib QNet. It's an official Grunt plugin. And then in QNet, we say blog post. And then we just point it to QNet index HTML. So that needs to be an array. QNet index.html. And this you need to npm install, but I've done that already. I cheated. And then you can just say grunt QNet. And it's going to start and say 3 assertions passed in 20 milliseconds. So you see it's pretty fast, and it's faster than doing it manually. A cool thing you can do is actually grunt npm. So is watch this file. So whenever you change your test or your file, it reruns the tests automatically and tells you if they pass or not. So we need to install the plugin that does that. And then I got to look at the docs because I forgot to do that. There we go. So I'm gonna copy this, and then I just wanted to quickly show you how this works to be actually a little more interactive instead of having to run it manually. You can say, first we gotta load the task that we just installed. Watch, and then you can say, okay, files, we just need blog post.js, and then we run qnit task. There we go. And then if you say grunt watch, oh, thank you. See, I removed too many commas, thanks. Now, if I change the blog post.js, I wrote it wrong. It's a blog-post. Actually, I can probably say star.js. Now, if I change my file, I run the watch task. I change my file. Say, hey, I want to change this to an H4. And then it tells me right away, hey, I expected this to be H6 published on, but I'm getting H4 published on. So this is pretty useful, and this is when testing is actually powerful, that when you write your stuff, you right away know. Quick excursion to optimize your workflow. This is part of what build tools and things like that do for you. Now, one big problem is Phantom run contrib qnit only runs on Phantom. So this tool, this plugin, only works with Phantom. It is very likely that my tests are going to fail somewhere else. I'm not going to say IE now. So that's actually a big problem, and it's still a kind of a young problem, newer-ish problem, is saying, hey, I need to run my tests in different browsers. How do I need a tool that says, hey, test it on my iPad, my Galaxy Tab, on Browser Stack in IE, and also run it locally and run it in Phantom. Maybe run it in Phantom first because it's fast, and if it fails, then we know everything else is not going to work either. But if it passes in Phantom, it can still fail in other browsers. So there's actually a whole bunch of tools that do that for you. I guess this is the third time. I'm going to talk about the one I wrote a while ago, which is test, which is basically running your tests that we just wrote in different browsers and then reports it back to the command line. Instead of telling you what it can do, I'm actually going to show you how it works. So if you look back here, is this too small? There. There's our tests and our test files. So what I can actually do is say, hey, test Jasmine index.html, Mocha index.html, and Qnit index.html. So throw them all up by default in Phantom. We're going to change the reporter so that we actually see what's going on, and then we'll start it. And you see, now this is useful, but the cool thing about this is that you can actually say, hey, run it in Safari and Firefox. And what it does then, instead of using Phantom, it actually fires up Safari and Firefox and runs each test in a chain for each browser. And then I get those results back. So we say, hey, Jasmine index.html on Firefox 32, here it on Firefox, and it just complains that it can't start Safari because it's still running. So I think it's one of the simulators, but I got an error. So this is basically how it works. We can test it in different browsers. Now, if you remember how we talked about Browser Stack, that they have an API, we can actually say, take those tests locally, make them available to Browser Stack, and then fire up a bunch of browsers like IE8 and the Android emulator on Browser Stack and report back to me what the results are. It's going to take a little bit, so I'm not going to do this. But technically, it's possible to run tests on any device. I wanted to set up this little device lab with my iPad and the Galaxy tab. So if you have time and if you still want to stick around, we can actually run the tests on those because it looks kind of cool to have them pop up there. But I wanted to quickly go into the second part, which is continuous integration. Continuous integration basically does what we just did on the command line on a different server for you. And when somebody breaks a test, yells at whoever broke it, or everybody. So how this looks, there's a couple. There's Jenkins, Cruise Control, and Travis CI. I'm using Travis CI a lot because they offer free CI. Do I have a good example? CanJS, Feathers. So here, they run it on a server for you. And as you can see, there's all the tests that are being run in different combinations and all those things. And whenever something fails, this happens when you push to GitHub. Whenever something breaks, it's going to report back to you. So that's continuous integration. Basically, what we can do, if this passes, we can say, hey, now automatically deploy it into production. So you get this, or not production, maybe staging, whatever you feel confident in doing. But instead of just uploading all your stuff and it's like, oh, it's going to work, and maybe somebody will complain if it doesn't, you can actually make sure that you have this pipeline of write your tests, run them, maybe on different devices on CI, and then the CI is taking care of either yelling at you for breaking the tests or of distributing them into your staging or production environment. So this can all be automated. You don't have to always go into FTP, upload your stuff, then click around in browser, make sure that it works. This is pretty powerful and a pretty common practice for anything that it should be common practice for just anything, period. So I was going to do some more coding, but we can maybe do that later. Because the last thing I want to talk about is functional testing, because that's more fun, because there's actually stuff happening. Functional testing is unit testing. We test our units, we write some code, make sure that what it spits out is what we expect. Functional testing, on the other hand, simulates user interactions. Say, hey, I want to scroll down there. If I click the login button and I don't put anything in, I want to see an error message. So you're changing your focus from what did I program and how do I test it to what would a user do on my website. There's actually a cool thing called Gremlin.js. Basically what this does, I love the name, and basically what it does, it's a JavaScript library that goes on your website and just tries to break it as hard as it can. So basically it emulates like random clicks, and then it presses delete buttons and sees what happens, and then you get a report back. So this is actually a cool project, also pretty cool name. So yeah, they just really try to break your website. I forgot, I haven't put that on the slides, but I totally should. Another tool that is a little less random, there are four that I want to talk about, want to mention. Zombie, that browser actually has an API where you can say, hey, type into this login form, then click the login button and see if you're logged in. Casper.js is using Phantom, is on top of Phantom, so you can write scripts of actually emulating user interaction. Say, again, type into, or first try to log in without username and password. What happens? I want to get an error message. Then type in a wrong password but a correct username. I want to get this message, right? So you can do that with Casper, and it throws it into Phantom.js. So it's all, you don't have to open a real browser for this. Again, the problem is you're not testing it on a real browser, but it works pretty well for basic acceptance functional testings. Selenium, I guess everybody who's working in a bigger environment might have heard about this. It's an automation tool that you can use to write automation in Java. This is what Sauce Labs uses internally. I think one of the founders is actually one of the original developers. And then one that's actually been around for a while, which is FunkUnit, conveniently also developed by the folks I work with. is basically a library that does your user interaction simulation all in the browser. So you can run your tests in the browser of people clicking, people typing, and things like that. And then you can make assertions. So let's say we want to type into the login again, and we want to get an error message. You make a jQuery selector and say, hey, my error message field should show up now. So this is kind of how it works. It runs on top now last year, so new stuff. Last year, this only ran with QUnit. Now it actually runs with Jasmine or Mocha. So basically, you are writing a QUnit, Jasmine, or Mocha test like we already saw, but instead of making assertions, you actually make user interaction. So if you look at this here, here we can say, hey, new to do, click, and then type into that field and do something, wait 500 milliseconds, then make sure that the list has one to do, things like that. How this actually looks, you can see on the website. My colleague actually wrote. So this thing is a to-do MVC. It's, if you're thinking about using a framework, go onto this page and actually look. It's the same app implemented in all those different frameworks. So you can look at the source, you can look at the demo code and things, but basically it's just a to-do app, right? But it helps actually a lot to evaluate if you like how the framework works and things like that. So what we want to do, and what they actually have a big problem with, is making sure that all the submissions follow the spec, right? Somebody wrote a new framework. It's like, here, I wrote to-do MVC in this framework. Does it show how many items are left? Can I toggle this stuff? Can I clear the completed? Can I delete one? So I think they have some Casper.js tests right now. I'm not sure, but we've created a to-do MVC FunkUnit example. And if I actually run this, here's the QUnit source code. If I actually run this, it does stuff, which I think is always pretty cool because it does stuff. And it makes all those assertions, and then when it's done, all your tests, like you see here in QUnit, actually pass. Now, there's two cool things about this versus doing it with something that runs just in Phantom. The first is you can run it in a browser. So you can run it on here, on mobile devices. You can run it anywhere. And because it runs on top of QUnit and Jasmine and Mocha, those tests can actually be run on Phantom on the command line with anything that can do QUnit tests. So what I just showed you with this actually also works for those automated tests. I can quickly do that. So we want to start FunkUnit. There are the examples on the GitHub as well. Index.html, and we want to run it in Firefox. And then I'm going to change the reporter because it's only using those dots. So I want to see what happens. So this one is a little more verbose. So let's see how this works. So you see how it runs the test for me and how it reports them back to the command line. So we are actually using this to test our individual components on CI. So instead of just making unit tests, because even with good unit tests, stuff is going to break, we can actually make sure that the user interaction that we expect people to do is actually going to work. They are a lot of work to maintain. You have to write jQuery style stuff. So you can say, hey, is it visible? Things like that. But it's worth it because if you hand it off to somebody else, when we bring on new developers on the team, they instantly know when they broke stuff because, well, continuous integration is going to yell at them and say, hey, your pull request doesn't pass. And then you can go and fix it. And that's so can only highly recommend it. If you have questions, if you have other tools that you'd like to share, I'd be happy to. I talked for an hour and a half. Yes, maybe just an hour, which is good. So if you have other questions, there were some things that came up about mocking, about actual debugging. We can go into that a little bit more after another 5-minute break. But I'm going to finish the Hangout for today. So thanks for watching, you 2 viewers. 2 stuck around, 5 started.